Welcome everyone. This screencast details the DevOps pipeline built by Vinita and Satvik. There were 4 milestones as a part of this pipeline. The first milestone was build server creation, wherein we used the Jenkins CI to configure the build environment. The other key tasks that were taken care of were setting up dependencies for the project, writing and running build script, configuring the project workspace, and triggering a build by pushing code to Git.
We have set up a link to the GitHub repository, our source repository. We've used the polling scheme, which would recognize any push that has been made to the GitHub repo and automatically trigger a change. So here, as you can see, the Git polling log detects the change build has been triggered. We can see that Maven goes in and cleans the repository that the workspace is using and installs all the dependencies. The build also on success shows the shell script that we have been running. The shell script can be configured here as one of the build steps. In order to achieve a multi-node build in Jenkins, we have set up a master-slave environment, as you can see here. This helps triggering a build on multiple nodes.
For the test and analysis milestone, we have used the following framework: Jasmine for testing, Phantom.js for the test runner, Jasmine Istanbul has been used for code coverage. We have also implemented randomized input for fuzz testing. We have used JSLint to perform static analysis and used the checkstyle plugin in Jenkins to determine the criteria to pass a build. There is also a Covertura plugin in Jenkins in order to pass or fail a build based on the coverage criteria. In addition to everything, there is another analysis performed by calculating the number of functions and the cyclomatic complexity of the code. This is the app that is under test. It has 3 questions and you can answer it true false, based on which it will give you correct, incorrect or not yet attempted. We have written a couple of tests for various kinds of inputs, whether you give the correct answer or whether you give the incorrect answer. I've also on the back end manipulated the true or false, as in to give an integer input, to give a float input, and also given randomized input to achieve fuzz testing, that is by reversing the strings that are true or false. So here I can see that a couple of specs pass and couple of them fail. I achieved this by running the Jasmine all command. It gives me the specs which pass and which do not pass. Also, I have measured the code coverage using the tool Jasmine Istanbul. So here it first runs the test and then it gives you the code coverage summary, and the code coverage can also be seen via an HTML page. We have configured the Jenkins CI to perform static analysis using the JSLint tool. Here I specify the files on which the JSLint tool should work. It gives an output in the form of a checkstyle result. You can see the files, the warnings, the details about these warnings, etc. We have also configured the Covertura coverage report plugin, which will go ahead and check your coverage report, which is in the form of an XML file. These are some of the coverage metrics that have been set. In case these are not met, we have configured Jenkins to fail the unstable builds. So as you can see from this console output, that since the stability criteria is 75 but it was around 67, the build was unstable and it failed. And you can also see the Covertura coverage report that is published on Jenkins. Additionally, there is an analysis.js file. It checks how many number of functions are present in the file and it calculates the cyclomatic complexity of the file.
As a part of our deployment milestone, we configured an auto deployment environment. We used AWS CloudFormation stacks as canary and production servers. We deployed the development and canary code on a different port, and we monitored the canary for failures in order to stop the code from being pushed to deployment. For the deployment milestone, in order to create the auto deployment configuration, we create 2 remote AWS CloudFormation stacks, which would serve as our canary and production servers respectively. Now, in order to push the changes that we send over to our repo onto these remote instances, we use the publish over SSH plugin that is provided by Jenkins. For this, we need our key for our particular AWS profile, and we need to give the EC2 instance addresses for those AWS instances that we are using. In order to really auto deploy an app, 2 things need to be done. One is the dependencies that the app needs have to be taken care of. We are doing this using the pre-build step in Jenkins. We are setting up Node.js on the environment. As a part of the post-build step, we are running the app forever using the forever command. Now, originally our app on the production server displays the message hello world, but when our canary is pinged, then the canary server shows this particular message. The IP address I'm showing here is the AWS instance with my canary relay. We now run a monitoring app on our canary which monitors the CPU usage, and as soon as the CPU usage reaches a value of 90, then the canary is killed.
For the special milestone, we have implemented the concept of a chaos monkey. Here we have 5 EC2 instances running as production servers and hence our potential targets. There is a proxy listening on the local machine. The chaos monkey has been designed to bring down random instances at random intervals of time, hence refreshing this list of potential targets. These 5 production instances are used as potential targets. I have a proxy listening on my local host at port 3000. This decides which production instance is to be chosen from the given list. The list of available servers gets refreshed every few seconds. You can see that some of the instances are removed and added after random intervals of time.
Thanks for watching.